So when we did the hand trick, what did the angles represent? Or what did our fingers represent our angles, which were what? Zero. And those ones on our table. The pattern sine and cosine, it's a square root over 2. And under the square root, we put the number of fingers, remember? Sine is the top and cosine is the bottom. So for instance, if I said 0, I fold in my 0. So on the table, when we filled it out, the sine of 0. How many fingers do I have above the one I folded down? 0. So it's the square root of 0 divided by 2, which is 0. So sine of 0 is 0. At the same time, cosine is the bottom. How many fingers do I have below the one I folded in? So it's the square root of 4 divided by 2, which is 1. So cosine of 0 is 1. If I wanted tangent, tangent is square root of the top over square root of the bottom. So tangent of 0, how many fingers above? 0. Below? 4. So we get 0 over 2, which is 0. So tangent of 0 is 0. Once we had sine, cosine, and tangent, we just did reciprocals to get the others. So like cosecant of 0 would be the reciprocal of sine. Reciprocal of 0 is undefined. So cosecant of 0 is undefined. Secant, the reciprocal of cosine, reciprocal of 1 would be 1. Cotangent, reciprocal of tangent would be undefined. And we filled out that whole chart using this trick. There are other tricks I can give you. Is the hand trick working okay? I know some of you weren't here, and that's fine, but those of you that were here, is that one working okay so far? Tomorrow we might do a short quiz, like a really basic. I'll even show you. You know, the first 6 questions are SOHCAHTOA, like I'm going to say sine, and I want you to write opposite over hypotenuse. And so I'll ask each of those 6 functions. The second one, I gave you a triangle, and I just want you, if I said sine of angle B, I want you to write the ratio from the triangle. And then the bottom, I put the first 3 rows off our table, sine, cosine, and tangent. So using our hand trick, I didn't put the reciprocals on there yet. Just to kind of practice so I can see if there's anything that I need to really go back and hit before we move forward. So I'd like to do that tomorrow. Today we're going to continue using this, and we're going to talk about non-acute angles. So angles that don't fall between 0 and 90. And our strategy with these are to use what are called reference angles. So this is a definition you might want to write down. With our reference angle, the notation, we use theta with a little tick mark next to it, theta prime. That represents a reference angle. And it is just the positive angle between the terminal side of theta and the x-axis. So let's write down what would happen in each quadrant. If I'm talking about an angle, if you are in quadrant 1, then your reference angle, if you have an angle in quadrant 1, reference angle is the distance between your angle, the terminal side of your angle, and the x-axis. That is the same as your angle. So if you're in quadrant 1, if you have something between 0 and 90, Your reference angle isn't anything different. It's just the same thing. If you are in quadrant 2, so if I have an angle that ends in quadrant 2, that means this is my angle. My reference angle is the distance from my terminal side to the x-axis. So this is my theta prime. How would I find that? The distance from here to that line. What if I said this was 100 degrees? My original angle is 100. What would my reference angle end up being? 80. How'd you get it? Right. This line is 180 degrees. So if you're in quadrant 2, you just have to do 180 minus your angle to get your reference angle. We're in quadrant 3. So if this is my angle in quadrant 3, the reference angle is between my angle and the x-axis, always the x-axis. So it's this piece right here. So like my angle in quadrant 3 might be 200. Then what would this turn out to be? How far is it to the x-axis? 20. In the third quadrant, your reference or your angle is bigger, so you do your angle minus 180. In the fourth quadrant, so if this were my angle, my reference angle is just this piece here between that and the x-axis. All the way around is how many degrees?
360.
So you would just have to do 360 minus your angle to get that. The reference angle itself should always be acute. It's always going to be something between 0 and 90 degrees. You always measure distance to the x-axis, so you should never subtract 90 or 270. You're always going just to the x-axis, so only using the 180 and the 360. Any questions there? So let's practice just finding reference angles to start. If my angle is 30 degrees, 30 is already between 0 and 90, so my reference angle is just 30. If it's already an acute angle, the reference angle doesn't change it. 135. What quadrant is that in? Quadrant 2. You don't necessarily have to draw a picture. You need to be able to pick out the quadrant. So to get my reference angle, we would do 180 minus 135, which is 45. 240. What quadrant is that in? 3. It's between 180 and 270, so it's somewhere here. So quadrant 3. So to get my reference angle, to get something between 0 and 90, we'd have to do 240 minus 180, which is 60. 330. What quadrant is that? Quadrant 4. So what do we do to get the reference angle? That's just 30 degrees. What would we do if we had negatives? Let's get the coterminal first. If you add 360, that's a 150. What quadrant is that in? Second. So how do I get my reference angle? Okay. Negative 140. So if I add 360, we get 220. What quadrant is that? Quadrant 3. It's between 180 and 270. So how would I get my reference angle? That's quadrant 4.
Does it say 220?
Yeah. Sorry. My handwriting's sloppy. So we're right here. So we would have to do 220 minus. And we get 30 degrees. Any questions there? Okay, so really all I want to do for the rest of the day is a combination of what we did Friday and this. The idea is on our table there are only 5 special values that we have to be able to evaluate our trig functions at. 0, 30, 45, 60, and 90. But we can extend that using reference angles to find more angles than just those. So, for instance, I want to find the exact value of the sine of 240 degrees. Exact value means not a decimal. When I give you these problems, there are 2 things that I will expect you to write down every single time as showing your work for this. I will ask quadrant and reference angle every single time. So if I am looking at 240, what quadrant is 240 degrees in? Quadrant 3. Reference angle. If you are in the 3rd quadrant, how will I get my reference angle?
280 plus 180.
And we get 60. So now, from this information, we're going to be able to write down our answer. In quadrant 3, is sine positive or negative? Negative. You guys remember that all students take calculus? Quadrant 3, tangent's positive, so sine is negative. So our answer is going to be a negative. And then, we just have to evaluate at our reference angle. I need the sine of 60 degrees. So using our hand, we've got 0, 30, 45, 60. So everybody fold in your 60 finger. The pattern for sine or cosine is square root over 2. Sine is the top, so how many fingers do I have above the one I folded in? So my answer is negative radical 3 over 2. Okay, when I give you an angle bigger than 90, you can evaluate it based on your reference angle. and you have to decide whether it's positive or negative from the quadrant you lie in. So Friday's homework would have just said sine of 60. So now we're extending it, so we have to pay attention to the positives and negatives as well. Any questions on how I got that? Let's do some more. Tangent of 315 degrees. Two things that we have to write down: quadrants, reference angle, every time. 315 is in what quadrant? Quadrant 4. Reference angle. In the fourth quadrant, reference angle is distance to the x-axis. So we do 360 minus 315. And we get 45 degrees. So then, quadrant 4. All students take calculus. We're talking about tangent. In quadrant 4, cosine is positive, so tangent would be negative. Then I have to do the tangent of 45. So remember, our trick for tangent was square root over square root. So if you fold in your 45, how many fingers above? How many fingers below? 2. So we get -1 for the answer. Okay. You guys try, at least give me the quadrant and reference angle information. Evaluate the whole thing if you can. What quadrant is 300 in? Quadrant 4. So reference angle, you do 360 minus 300. We get 60 degrees. So cosecant, that wasn't one we did on our hand trick, was it? But it's the reciprocal of sine, so we can figure it out. First of all, in quadrant 4, sine positive or negative? Negative. So our answer will be negative. 0, 30, 45, 60. So sine of 60, using our hand trick, is radical 3 over 2. Cosecant would flip that. So 2 over radical 3, but we can't leave the radical on the bottom. So we get -2 radical 3 over 3 for the final answer. Okay. So far, so good? Let's do, I'm kind of skipping around today, so bear with me. Let's do this one. Example 5 here. sine squared 45 degrees plus 3 cosine squared of 135 degrees minus 2 times the tangent of 225 degrees. So we have to evaluate a lot of things here. Remember when you see that sine squared 45, that means find the sine of 45 and then square your answer. Since 45 is already in quadrant 1, we can just evaluate. So if you fold in your 45, sine is the square root over 2, sine is the top, so it would be radical 2 over 2. Plus 3. I need the cosine of 135 squared. What quadrant is 135 in? Second. Reference angle, 180 minus 135, 45. Okay, in the second quadrant, is cosine positive or negative? Negative. Cosine of 45, so if you fold in the 45, cosine is the bottom, square root of 2 over 2. Minus 2 times the tangent of 225. What quadrant is 225 in? Three. Reference angle. In third quadrant, you do 225 minus 180. No, 45. In the third quadrant, is tangent positive or negative? Positive. Tangent of 45 would be the square root of 2 over the square root of 2, which is just a 1. So now if I simplify this, this would be radical 2 squared is 2 over 4, so 1/2, plus 3. When you square a negative, it becomes a positive 1/2. So this would be, if you add those 1/2 and 3/2, that's 2 minus 2, and we get 0. One more example and then I'll be done. Any questions on this one? Okay, this one I'm asking backwards. I want to find theta if theta is between 0 and 360 and sine of theta equals negative radical 3 over 2. So we have to get our angle here. If I start with this statement, what I see there is that sine is a negative. In which quadrants is sine negative? 3. They're all positive in 1. Sine is positive in 2. So it would have to be quadrant 3 and quadrant 4. So I'm going to have two answers, one for each of those quadrants. Reference angle. What makes sine radical 3 over 2? So if I think about sine, like sine of 0 would be 0 over 2. Sine of 30 would be radical 1 over 2. 45 radical 2 over 2. 60 is radical 3 over 2. So my reference angle has to be 60 because that's what makes sine radical 3 over 2. So now we're going to put our angle in each of those quadrants. So if you think about in quadrant 3, if your reference angle is 60, what would the whole angle be? How would I get that? How far is it from here to here? 180, and we need 60 beyond that, so you'd have to do 180 plus 60, so we get 240 degrees. In quadrant 4, this is 60. I need this. We know the whole thing is 360. So if I did 360 minus 60, that little missing piece is 300. So the 2 times when sine would be a negative radical 3 over 2 is at 240 degrees and 300 degrees. Any questions there? That is my stopping point. So just a few things. This homework is going to be due on Wednesday. Tomorrow you're going to have some class time to work, and I'm also going to teach part of the class period. So you will have class time, it's not due tomorrow. We will have that short quiz tomorrow, talking about the SOHCAHTOA definition and the first 3 rows of the table. Also, I know you guys, for dual credit, MACC will be here February 3rd. So that is like a week from Wednesday. I'm probably going to give you those packets a little bit later this week. So you'll have those. But just a reminder, remind your parents, that will be February 3rd, and we'll fill out those packets together probably Wednesday or Thursday this week. Alright, and you have like 16 minutes right now to get started and ask for help if you need it.